Hey everyone! In the last section, we talked about the gas laws and how different things can affect the pressure of a gas. So, for example, we learned that temperature, if it increases, pressure will also increase. We learned about volume. If volume increases, pressure actually decreases. And then we learned about number of particles. If the number of particles increase, then pressure is going to also increase. This is going to be part 2 of our gas laws. A French physicist, Jacques Charles, collected data on the relationship between temperature and volume of gases. Because instead of relating temperature and volume to pressure, we wanted to see how does temperature and volume affect one another. And he took this information and he put it on a graph, and it showed a direct relationship between the volume of a gas and the temperature of a gas. So what that means is as the temperature went up, the volume also increased. And remember, this again is a direct relationship. Charles actually extended this graph after he plotted the points. So here we have one point plotted, he plotted another, and he saw that they were making a linear line. And so he connected all those lines and he extended those lines. So this dotted line is an extension. And he wanted to see where did it cover this x-axis or cross this x-axis. So in other words, what would the temperature be if he made the volume be 0 liters? And he saw that it crossed this x-axis right here at about negative 273.15 degrees Celsius. This temperature is actually going to be equal to 0 Kelvin on our Kelvin scale. And remember, Kelvin is our SI unit of temperature. This temperature at 0 Kelvin is known as something called absolute zero. You cannot get colder than absolute zero. And remember, we've tried to get things to absolute zero, and this is where we start creating the phase of matter, Bose-Einstein condensate, or BEC, that we talked about. Now, Charles took this information and he created something called Charles' Law. And this law basically states that the volume is directly proportional to temperature as long as temperature is in kelvins, that's the important part, and pressure and number of particles have to be held constant. In other words, they have to be the same. And he created an equation where he said if I took the volume of gas 1 and the temperature of gas and that temperature of the gas in Kelvin, it's going to be equal or proportional to the volume of the gas after a change versus temperature of the gas after the change. And this is really cool because if you guys ever take any higher level science, we can see how if I was given 3 of these things, I can actually find my last variable. Another scientist who also came up with a law was Robert Boyle. He wanted to look at the relationship between pressure and volume, and we've talked about this relationship before, but this is actually showing it in graph format. Here he has a gas within a cylinder, and at a volume of 0.5 liters, the pressure is about 200 kilopascal. And what he did was he actually increased the volume right here, and notice that we have more volume, but my pressure actually went down. And then here, he increased the volume in this container even more and saw that the pressure went down again. And we saw that connection. And we see that as volume goes up, pressure actually goes down. And you should associate Boyle's name with volume and pressure as well. And he created a law that basically states that the volume is inversely proportional to the pressure. And all that means is if volume goes down, pressure goes up, and vice versa, as long as the temperature and the number of particles stay the same or are constant. And his equation that he came up with was P1 V1 equals P2 V2. So again, P1 and V1 are going to represent pressure and volume of a gas before a change, and P2 and V2 represent the pressure and volume after the change. So for example, what I mean before and after the change, maybe we have a gas in a container with a 0.5 volume. Maybe I increase that volume to 1 liter. That's a change and it's going to affect my pressure. The last thing is we can actually take Boyle's law and Charles' law and take them to combine them into a single law called a combined gas law. And a combined gas law is very nice because it shows how temperature, volume, and last but not least, pressure are going to be related when the number of particles is constant. So the three things that we're looking at on this equation is going to be pressure, volume, and temperature. And we can see how changing these things are going to affect how my gas reacts and behaves. And to end it out, it says balloons like this one are used by scientists to gather data about Earth's atmosphere. The balloon is actually filled with hydrogen or helium, which is going to be lighter than air. And it's going to carry this big, huge balloon and a package of weather instruments up into the atmosphere for us to collect data. And gas laws are going to explain the behavior of this gas in this balloon. And that's the end of today's lesson. Let me know if you have any questions, and I hope you guys have a great day.